Now we'll discuss the question number 28, and the question is: a steel wire is drawn from an initial diameter of 10 mm to a final diameter of 7.5 mm. The half cone angle alpha of the die is 5 degree and the coefficient of friction between the die and the wire is 0.1. Now the average of this initial and final yield stress is 350 megapascal. The equation for drawing a stress is given as. So the expression for that drawing a stress, that sigma F, which is equal to that sigma Y, which is average yield stress, then into that 1 plus 1 upon mu cot alpha into 1 minus df upon di to the power 2 mu cot alpha. So this is the expression for that drawing a stress. Now in this question we have to find out the drawing stress required to carry out this operation. So the given data we have di, which is equal to 10 mm, final diameter, which is equal to that 7.5 mm, then half of the cone angle alpha, which is equal to that 5 degree, and coefficient of friction mu equal to 0.1. So in this we have to find out the drawing stress in megapascal. So just put the value of that average yield stress, coefficient of friction, then half of the die angle, final diameter and initial diameter into this equation. You will get the value of the drawing stress, and that sigma Y average, which is equal to that 350 MPa. Now put the value of average yield stress, coefficient of friction and that die angle and diameter into this equation. So that sigma F, which is equal to 350 multiplied by 1 plus 1 upon 0.1 into cot 5 into 1 minus df is 7.5 upon 10 to the power of this 2 into 0.1 into cot 5. So by solving this equation you will get 316.24 megapascal, which is the value of your drawing stress. So in this the expression for that drawing stress was given, and we had to put the value of the average stress, initial diameter and final diameter, and then coefficient of friction and half of that cone angle into this equation. You will get the value of that drawing stress in megapascal.